Okay, today we're going to practice our log differentiation by differentiating y equals 10 of ln of ax plus b. So the first thing that we're going to realize is that this is a composite function. It's actually a composite function of three functions. So this is actually 10. That looks like fan. I'm going to change that. This is actually tan x composed with ln x composed with ax plus b. So this is f of x, this is g of x, and this is h of x. And this is f of g of h of x. Okay, so that is what we're dealing with here. And because there is no rule for logs with a sum in the argument, we're just going to use the chain rule. We're just going to use f prime of g of x times we're going to use f prime of g of h of x times g prime of h of x times h prime of x. Okay, so I'm going to write that down. No, that's not the right color. I'm going to write that down up here. It's going to be our second note. I'm going to write down that we're going to use f prime of g of h of x times g prime of h of x times h prime of x. Okay, so this is what we're going to be doing. This is all pretty straightforward. It's just, it looks really complicated because there's a lot of moving parts. But I'm just going to work from the left to the right. I'm going to number our steps so that it's all a bit easier to understand. I'm going to use different colors so we know what we're doing. So here's our first step. It's going to be implicit differentiation, but y is on one side, so it really doesn't matter. It's just going to become dy over dx equals dy dx of tan ln of ax plus b. Okay, so the first thing that we're going to do is we're going to take the derivative of the outer function, and that's going to be secant squared because the derivative of tan x is secant squared x. So that's going to be secant squared of, and now I'm going to change colors. I'm going to actually change colors here so that we understand which function is what. Now we're going to just put in ln of ax plus b. I gave myself too much space there, but that's okay. Let's get rid of that actually. It doesn't look good. It doesn't look good. Let's just erase that real quick and fix it. Okay. So now we're going to multiply this. We're going to multiply this by the derivative of ln of ax plus b. So we're going to make that ln of ln, well, it's the prime of ln. So ln prime of ax plus b times ax plus b prime. What's a good color? Something that stands out. Plus ax plus b prime. All right, so now that we know this, we're going to just take the derivatives of each thing. So now we have secant squared x of ln ax plus b. We don't need to worry about that anymore. That's sorted. Now we have to take the derivative of ln x here, and the x is ax plus b, and the derivative of ln anything is 1 over the argument, so 1 over anything, 1 over ax plus b in this case. So it's going to be 1 over ax plus b times the derivative of ax plus b, and the derivative of a sum is the sum of its derivatives, so we're deriving We are deriving ax with respect to x, and we are deriving b with respect to x. B and a are constants, and x has the exponent 1, so this is just going to become secant squared x of ln of ax plus b times 1 over ax plus b times a, and that's all. So that makes our solution. We're going to put our solution up on the right hand side. Our solution is going to be in, let's make it blue, our solution right here, solution dy over dx, which is the derivative, which is the slope of the tangent line. It's like writing y prime. I'll just do it. Is secant squared of ln ax plus b times a over ax plus b. And that is our solution.